Okay, so today we're going to go ahead and talk about parallel circuits. Parallel circuits are circuits where the current can split and go multiple directions. So for example, we have this good old 10-volt battery right here. The current will go through this, and then at this junction, some will go through here and some will go through this wire right here. And then it'll recombine right over here. The cool thing about parallel circuits, like this is how houses are oftentimes wired, if one resistor goes out, that doesn't mean that the other resistor will go out as well. So we're going to find a couple things about parallel circuits. The first thing we're going to learn how to do is find the equivalent resistance, which is also just another name for R total. So in a parallel circuit, our equation to find total resistance is going to be 1 over R equivalent is going to be 1 over R1 plus 1 over R2 plus 1 over R3, etc., depending how many there are. So let's go ahead and find the total resistance of the circuit looking at this thing right here. So we know that 1 over R equivalent is going to be 1 over 6 is the first resistor plus 1 over 4 is the second resistor. So let's see. I go ahead and put in 1 over 6 plus 1 over 4 in my handy dandy calculator, or you can do some good common denominators, even better than me, and I get 0.42. So I know 1 over R equivalent is 0.42. So now to solve, let's see, I can multiply both sides by R equivalent. R equivalent cancels out over here. So now we have 1 equals 0.42 R equivalent. Now I can go ahead and just divide 0.42, 1 divided by 0.42. So I am getting 2.42 ohms for the total resistance. So that right there is going to be the equivalent resistance for this circuit. Cool. Questions on that? Great. So go ahead, write that down, make sure you have it there, and then we're going to go ahead and talk about the next thing. Okay, so we just found out how to find R equivalent, which is 2.42 ohms. And again, for series, or for any type of circuit, series or parallel, I always look at the totals first. So equivalent resistance was 2.42. Total voltage we know is just the battery, so I'm going to say V total is going to be 10 volts. Now let's go ahead and see, oftentimes let's go ahead and find the current total. That's nice to find. So I'm going to use V equals IR for that. So V I know is 10. I want to find resistance is 2.42. Great. I go ahead and do some good old math. I'm getting the current to be 4.17 amps. And again, this is the total current. So now let's go ahead and think about this. So parallel circuits are slightly different than series. So in a parallel circuit, we just talked about the current can split directions. So is the current going to stay the same or change in the circuit? It looks like it's going to change because not the same amount of current or like electron flow is going to flow down each resistor. While the cool thing about parallel circuits, which is why they're so great for like wiring houses or other things, is the voltage will stay constant through each thing. So both the 6 ohm resistor and the 4 ohm resistor will get the same total voltage of 10 volts, which is the total voltage. So let's go ahead and use that. So I know the resistance for each of them. I'm going to go ahead and write down so I know, let's get in this color. So the voltage is 10 volts for each of them. Cool. Let's go ahead and solve for the current for each of them. So let's find the current down each branch. So we can use, again, V equals IR. So in this case, V is 10. I don't know. Resistance is 6. And I get current to be 1.67 amps for this one. So I'm going to put that in, 1.67 amps. Cool. For the other one, again, let's use V equals IR. V10, we don't know. R equals 4. Go ahead and do some good old math. I get the current to be 2.5 amps. Cool. So now let's go ahead and look at this and talk about different points. So again, current flows like this. So right here at this point right here, how many pathways are there for the current to flow? It looks like to me there's just one pathway. So it's going to get the full total current, which is going to be 4.17 amps. Cool. So now right here it'll split. Okay. Does more current want to go with a high resistance or a low resistance? More current is going to go with a low resistance, which, oh my goodness, our math works out. this is 2.5 amps over here. It's going to get more current than the 1.67 over here. Cool. So all the way down this one through B, this whole thing, it's only going to get 2.5 amps of current. While when it goes down, I'll go ahead and draw it in a different color. It goes through A, it's going to get 1.67 amps. So here we have 1.67 amps, and here we have 2.5 amps. When they combine right here and here, what are we going to get? So we'll just combine those two current flows. So we'll get 1.67 plus what? 2.5? Let's go ahead and add those together. Oh my goodness, physics is so fun. I get 4.17 amps, which is so cool. Those go ahead and combine to be the total current in the parallel circuit. Cool. So thanks for solving this problem with me. The one main thing that I want you to remember for this one is that total voltage drop across each resistor is always the same in a parallel circuit. So that's going to be the most important thing that we remember about parallel circuits. While the current is going to be different through each one because there's different pathways for it to flow, but the current through each resistor will go ahead and sum to be the total current in the circuit.